Students, you people have studied about Bohr's atomic model as well as its limitations. In view of shortcomings of Bohr's atomic model, efforts were made to develop new atomic model to overcome the limitations of Bohr's atomic model. The development of new atomic model was mainly based on two concepts: dual behavior of matter as well as Heisenberg's uncertainty principle. So based on this, the new branch of science was developed known as quantum mechanics, also called as wave mechanics. So this quantum mechanics considers both wave as well as particle nature of matter. So Bohr's atomic model was mainly based on the Planck's quantum theory, whereas the quantum mechanical model of atom based on the dual behavior of matter. So it is very necessary to study the dual behavior of matter as well as Heisenberg's uncertainty principle. So let us study one by one. Let me discuss about dual behavior of matter first. In 1905, Einstein suggested that light shows the two behavior. It has dual character, that means it shows both wave-like as well as particle-like nature. In 1924, Louis D. Broglie, a French physicist, he advanced that all material particles, microscopic as well as macroscopic, electron, photons, or a piece of chalk, piece of stone, ball, etc. So all the moving material particles, they possess dual behavior. That means they show both wave-like as well as particle-like nature. So this was a statement given by Louis D. Broglie. The wave which is associated with that particle is called matter wave or de Broglie wave. We had given a relation which is known as de Broglie's equation. So which is lambda is equal to h by mv. Lambda means wavelength of a wave associated with the particle, whereas h is Planck's constant. We know the value of Planck's constant, 6.626 into 10 to the power minus 34 joule second, whereas m is the mass of the particle. V stands for velocity, that moving particle. And you people also studied that the product of mass and velocity is nothing but momentum, which is represented by letter P. So we can also write the de Broglie's relation as lambda is equal to h by p. See here, lambda is inversely proportional to m, mass. Mass and wavelength, these two are inversely proportional. Let me discuss the significance of de Broglie's relation. For this, I will take two examples, macroscopic as well as microscopic object. Let me compare. See, consider a ball of mass 0.1 kg moving with a speed of 60 meter per second. Okay? So ball here, a macroscopic object. Let us calculate the wavelength of this particular object. So we have to use the expression lambda is equal to h by mv. Let us substitute h. Here h is Planck's constant, 6.626 into 10 to the power minus 34 joule per second divided by mass. Mass is 0.1 kg. Let us substitute over here 0.1 kg into velocity 60 meter per second. for the unit simplification, joule is nothing but kg meter square per second square. You want to simplify by taking, instead of joule, you want to substitute kg meter square per second square. So show the unit simplification first. Joule means, let us write kg meter square per second square, and here second divided by kg is there in the denominator, kg into meter per second. Here second square per second square into second per second per second per second cancels, meter meter, kg kg. So the unit is your meter. Wavelength is expressed in meter here. Now, if we simplify this, 6.626 into 10 to the power minus 34 divided by 0.1 into 60, we get 10 to the power minus 34. Answer we get as 10 to the power minus 34 meter. Okay. So this is a wavelength of a macroscopic object with the mass 0.1 kg. Now, let us calculate wavelength of a electron, which is a microscopic material particle. Electron, a microscopic particle. Let us calculate the wavelength of this electron and let us compare. Same formula is used here also. Lambda is equal to h by mv. H is Planck's constant. Now substitute H is Planck's constant. And the mass, we know the mass of electron, which is 9.1 into 10 to the power minus 31 kg, or it is approximately equal to 10 to the power minus 30 kg. Okay, for the simplification, we have taken 10 to the power minus 30 into 60. Into 60. So the unit simplification is same as I discussed in the earlier problem. Then wavelength lambda is equal to 10 to the power minus 5 meters. See, for the macroscopic object, we got the value lambda value 10 to the power minus 34 meter, whereas for the microscopic we got 10 to the power minus 5. Now let us compare here the values, two values, 10 to the power minus 34 and 10 to the power minus 5. 10 to the power minus 5 is greater than 10 to the power minus 34. That means the wave property associated with the microscopic particle, that is electron, which is greater than that of what? A ball, than that of the wavelength of a ball. 10 to the power minus 34, much smaller than 10 to the power minus 5. What I am going to say is here, as I have mentioned, wavelength and mass, these two are inversely proportional. Larger the mass, smaller will be the wavelength, or smaller the mass, greater will be the wavelength. So that's why de Broglie's relation has no significance on macroscopic objects. We come across bigger objects in our daily life, like moving bus, moving car. Yes. But the wavelength or wave properties of these bigger objects cannot be identified easily because of their large mass. So remember students, wavelength and mass, these two are inversely proportional. Larger the mass, smaller will be the wavelength. So we can conclude that de Broglie's relation is significance only for microscopic objects. It has no value or less significant in case of macroscopic, larger moving objects. Now let us solve some problems, numerical problems using de Broglie's equation. So this one is very important. question. Write de Broglie's relation. Explain the terms, which will come for 2 mark. 2 mark you have to mention that lambda represent wavelength of a particle, moving particle. H is Planck's constant. M mass of that moving particle. V is its velocity. Okay, for the 2 mark. Either you can write lambda is equal to h by mv or lambda is equal to h by p. Let us see some problems. Read out the question. What will be the wavelength of a ball, a macroscopic object of mass 0.1 kg moving with the velocity 10 meter per second? Okay, same formula. Lambda is equal to h by mv. This formula you have to use. Substitute for h is Planck's constant 6.626 into 10 to the power minus 34 joule second divided by mass 0.1 kg into velocity 10 meter per second. For the unit simplification, you have to take joule as equal to kg meter square per second square. Okay. Then after simplification, we will get final answer as 6.626 into 10 to the power minus 34 meter. Unit is important one. Along with final answer, you need to show the unit answer. Okay, the correct unit. Here it is meter. Velocity is expressed in meter per second. So the lambda is expressed here in meter. Next problem. Calculate mass of a photon with the wavelength 3.6 angstrom. 3.6 angstrom. This is a question. Calculate the mass of photon with the wavelength 3.6 angstrom. You want to calculate the mass of a photon. M means how much? Where wavelength was given here, lambda 3.6 angstrom unit. So wavelength is usually expressed in meter unit. If it is expressed in other than meter unit, you need to convert. Now it is in angstrom unit, so we know that 1 angstrom is equal to 10 to the power minus 10 meter. So 3.6 angstrom is equal to 3.6 instead of angstrom, take 10 to the power minus 10 meter. First, convert angstrom to meter unit. Then, use the formula de Broglie's equation h by mv. Okay. We have to calculate mass. So, rearrange the expression. M is equal to h by lambda into v. Now, let us substitute 6.626 into 10 to the power minus 34 joule second divided by lambda. Be careful by substituting lambda. Take 10 to the power minus 10 unit here. 3.6 into 10 to the power minus 10 meter into velocity. See, in question velocity is not given. You want to substitute velocity, but they have mentioned there that calculate the mass of photon. Photon means we know these are the small packets, energy packets of light. So light radiation travels with the velocity of how much? 3 into 10 to the power 8 meter per second. So that will be the velocity of photon. Okay. So this you have to write. It is not given in the question. So velocity of photon is nothing but velocity of light radiation, whose value is equal to 3 into 10 to the power 8 meter per second. So let us substitute over here 10 to the power 8 meter per second. So after the simplification, we will get 6.135 5 into 10 to the power minus 3 kg. Next problem. Mass of electron is 9.1 into 10 to the power minus 31 kg. If its kinetic energy is 3 into 10 to the power minus 25 joule, calculate its wavelength. Again, the Broglie's wavelength must be calculated. Lambda is how much? What was given here? Mass of electron. Electron, a microscopic particle. Its mass was given 9.1 into 10 to the power minus 31 kg, and also kinetic energy of that electron is given here. Ke, kinetic energy, moving energy is equal to 3 into 10 to the power minus 25 joule, energy expressed in joule. Calculate wavelength. Lambda is how much? We know that expression for kinetic energy is equal to half mv square. We will have studied kinetic energy equation, half mv square. So before calculating lambda, we should calculate velocity, because velocity is not there, not mentioned there. That's why using the kinetic energy, we have to calculate velocity, then we have to substitute it in the de Broglie's relation. So v square is equal to, just to rearrange it, it goes to here 2kT by m mass, or velocity is equal to, take square root of this term, 2kE by m. Substitute here, V is equal to square root of 2 into kinetic energy, 2 into 3 into 10 to the power minus 25 whole divided by mass, 9.1 into 10 to the power minus 31 kg. On simplifying, we get V is equal to square root of 0.0659 into 10 to the power 6. Okay. Use your calculator for the simplification. Then square root of 10 to the power 6 is very simple, 10 to the power 3. Okay, 10 to the power 6, square root of it is 10 to the power 3. Then if you take the square root of this term, we will get 0.8117. V is equal to, or shift the point, decimal point, towards the right by 3 places. So that 811.7 into, if we shift the decimal point towards the right by 3 places, what we get? 10 to the power minus 3. The decimal point is shifted towards the right, so we have to take the negative values over here. 10 to the power minus 3 into 10 to the power 3. So 10 to the power minus 3 plus 3 cancels. Now we have 811.7 meter per second velocity, so meter per second, or we can also take as V is equal to 812 meter per second. So we have calculated just velocity of the electron. Now we have to substitute this velocity in lambda is equal to h by mv formula. Lambda is equal to h by mv formula. Lambda we want to calculate 6.626 into 10 to the power minus 34 divided by mass, electron, mass of the electron 9.1 power minus 31 kg into 812 meter per second. So after the simplification, we get 8967 into 10 to the power minus 10. Take the unit of wavelength as meter. Okay, velocity is in meter per second, so this will be meter unit. So this is how we can solve the problem. Okay, where kinetic energy was mentioned. So initially, how to take kinetic energy is equal to half mv square, so that we can calculate velocity. So once we calculate the velocity, we have to substitute in de Broglie's relation. Lambda is equal to h by mv. That gives the de Broglie's wavelength. Hope you understood. Now to discuss the next concept, which is also important one, Heisenberg's uncertainty principle. All moving objects which we see around us, like moving car, moving bus, planets, ball thrown in the air. Yes. So these objects, they travel in a fixed path or in a fixed trajectories. So the calculation of the position as well as the velocity of that particular object, that will be easy. Okay. With the accuracy we can calculate. But in case of subatomic particles, the exact position as well as velocity of that moving particle, minute microscopic particle, cannot be done accurately. We'll end up with the uncertainty, get error. So which was stated by Heisenberg. So Heisenberg's uncertainty principle, it states that it is impossible to determine simultaneously, andre ottige onde time ige the exact position, adra position ellirtade a vastu minute particle, and the exact momentum or exact velocity. Momentum means we know m into v, velocity. Mass is constant but velocity changes. So momentum or velocity cannot be determined simultaneously of a subatomic particle or an electron. See the important definition which will come further to mark. State Heisenberg's uncertainty principle. It states that it is impossible to determine simultaneously at the same time, ಒಟ್ಟಿಗೆ ಒಂದೇ ಟೈಮಿಗೆ ನಿಮಗೆ ಅದರ ಪೊಸಿಷನ್ ಅದೆಲ್ಲಿರ್ತದೆ ಪಾರ್ಟಿಕಲ್ ಮತ್ತು ಅದರ ವೆಲಾಸಿಟಿ ಏನು ಅಂತ ಕಂಡುಹಿಡಿಯಲಿಕ್ಕೆ ಆಗುವುದಿಲ್ಲ at a particular time. So this was a statement stated by Heisenberg's uncertainty principle, and the mathematical expression which was given by Heisenberg was delta x into delta p, which is equal or greater than h by 4 pi. So delta x and delta p. So what is the meaning of this delta, sign delta? So delta represents your uncertainty. Uncertainty means not sure. We are not getting the accurate value. We will get some error. Okay, we are not sure about the position and velocity of microscopic objects. So the statement, mathematical expression was given as delta x into delta p, which is equal or greater than h by 4p. Delta x means position, uncertainty related to position. Delta p, uncertainty related to momentum. X for the position of that particle, p means momentum, mass into velocity. Uncertainty means ನಿರ್ದಿಷ್ಟ ನಿಖರವಾಗಿ ನಿಮಗೆ ಅದನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಲಿಕ್ಕೆ ಆಗುವುದಿಲ್ಲ, ನಿಮಗೆ ಎರರ್ಸ್ ಇರ್ತದೆ. ಅದೇ ನೀವು ಮ್ಯಾಕ್ರೋಸ್ಕೋಪಿಕ್ ಆಬ್ಜೆಕ್ಟ್ಸ್ ತಗೊಂಡ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಬಸ್ ಮೂವಿಂಗ್ ಫ್ರಮ್ ಒನ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಟು ಅನದರ್ ಪಾಯಿಂಟ್, circular path, we can calculate, we can determine the position as well as the exact, almost exact velocity of that moving bus with the very minimum error, with the very less error. But it is not possible in case of microscopic. So because in both atomic model, you people have studied that electron is revolving around the nucleus in circular path, definite, fixed path. If there is a fixed path, one can easily calculate, one can easily determine the position as well as velocity of the moving electron. So after the Heisenberg's uncertainty principle, so it rules out the existence of trajectories or definite paths for the electrons around the nucleus. So let me talk about the mathematical expression here. So as I said, delta x is uncertainty in position, delta p uncertainty in momentum or uncertainty in velocity in the error equal to S which is equal or greater than h by 4 pi raised to pi means we know the value of pi 3.14. H is Planck's constant. So the students remember the statement as well as mathematical expression very important for 2 mark question. Either state Heisenberg's uncertainty principle for 1 mark or write mathematical expression, explain the terms. You have to explain these terms. Now, we can also write Heisenberg's uncertainty principle by substituting the momentum term. We know that momentum is equal to the product of mass and velocity. Momentum is nothing but mass and velocity. So, substitute over here delta x into delta t means m into v, which is greater or equal to h by 4 pi. Or see the mass is always constant, isn't it? It is not changing mass, but the velocity will change. So the mass is constant. That's why we take mass from delta x into m into delta v is equal to or greater than h by 4 pi. Or take this mass term here, delta x into delta v, which is equal or greater than h by 4 pi m. Either we can use delta x, delta v, h by 4 pi or delta x, delta v, h by 4 pi m. For solving the numerical problems, remember you have to take equal sign. Okay, for writing the expression you have to write greater than or equal. For solving numerical problems, you need to take equal sign. Okay. Delta x is uncertainty in position. Delta p or delta v is uncertainty in momentum or velocity of the particle. Let me give you 2 examples, microscopic as well as macroscopic. Heisenberg's uncertainty principle also applicable only in case of microscopic particles. It is less significant in case of macroscopic objects. Let us see how. Suppose we attempt to determine the position as well as the velocity of electron. We have to use microscope to observe the electron. We have to use the microscope. We have to focus light on that electron. Light energy need to be supplied. Now, whenever the light beam or the photon strikes the electron, both the position as well as velocity of that particular electron will change. So, both position as well as velocity are disturbed whenever the light radiation strikes the particle. So, we will get error, that means uncertainty will be maximum in case of both position as well as delta x as well as delta v, that will be more in case of microscopic objects. Now let us consider a rat. Okay, ಕತ್ತಲೆ ಕೋಣೆಯಲ್ಲಿ ಇಲ್ಲಿ ಓಡ್ತಾ ಇದೆ. Suppose if we focus the torch light on that moving body, rat, then what will happen? Nothing will change, means the position as well as velocity of that moving rat will not change by this light. What I am going to say is here, light energy is insufficient to change the position as well as velocity of moving electron. Light radiation ಏನು ಪಾಸ್ ಮಾಡ್ತೀರಾ ಅದಕ್ಕೆ ಅಷ್ಟು ಎನರ್ಜಿ ಇಲ್ಲ. ಇಲಿಯನ್ನು ಆ ಪ್ಲೇಸಿಂದ ತೆಗೆದು ಬಿಸಾಡುವಷ್ಟು ಎನರ್ಜಿ ಇಲ್ಲ ಲೈಟ್ ರೇಡಿಯೇಷನ್ಗೆ. ಸೊ ಇಟ್ ಈಸ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ಚೇಂಜ್ the position as well as velocity of macroscopic object body, bigger bodies. But whenever we use the light, we focus the light on electron, the position as well as velocity will change. So this is how the Heisenberg's uncertainty principle is applicable only for microscopic objects. That means it is not possible to determine the position as well as velocity of microscopic particle, but we can easily determine the position as well as velocity accurately of the bigger bodies or moving objects like moving bus, moving car. We can easily find out, we can easily calculate the position as well as velocity. Even Heisenberg's uncertainty principle also has no significance on macroscopic objects. Both de Broglie as well as Heisenberg's uncertainty principle holds good only for microscopic objects. The significance of uncertainty principle. Effect of Heisenberg's uncertainty principle is significant only for the motion of microscopic objects. Andre now microscopic objects alli matra find out ಮಾಡಲಿಕ್ಕೆ ಆಗುವುದಿಲ್ಲ ಒಟ್ಟಿಗೆ simultaneously velocity ಮತ್ತೆ ಅದರ position, but it is negligible for that of microscopic objects. ಅದೇ ನೀವು ದೊಡ್ಡ ಆಬ್ಜೆಕ್ಟ್ಸ್ ತಗೊಂಡ್ರೆ ಮೂವಿಂಗ್ ಬಸ್ ಮೂವಿಂಗ್ ಕಾರ್ ತಗೊಂಡ್ರೆ ಎರರ್ ನಿಮಗೆ ಕಡಿಮೆ ಸಿಗ್ತದೆ. will easily calculate the position as well as velocity of macroscopic objects. Then it rules out the existence of definite paths or trajectories of electrons and other similar particles. If there is a definite path for the movement of that particle, the determination of velocity as well as position will be done easily. That will be easy for us. So the Heisenberg's uncertainty principle rules out the existence of, please make a note of this point, it rules out the existence of definite path or trajectories for electrons and other simple or smaller subatomic particles. Now let us see some numerical problems using this Heisenberg's uncertainty principle. So as I said, for solving the numerical problems, take equal sign in expression. A microscope using suitable photon is employed to locate an electron in an atom with a distance of 0.1 angstrom. What is the uncertainty involved in the measurement of its velocity? So what was given and what was asked? Microscope, using microscope, photon and hakidare avra mele to electron. Okay, so here a photon is used to locate electron in an atom with a distance of 0.1 angstrom. The delta x is given here 0.1 angstrom. Uncertainty in a position is 0.1 angstrom. What is the uncertainty involved in measurement of its velocity? That means delta v is how much? Okay, this one you have to calculate. We know that delta x into delta v is equal to h by 4 pi m is equal to h by 4 pi delta x into m. ಇದನ್ನು ಇಲ್ಲಿ ತಗೊಂಡು ಹೋಗಿ delta x into m. H is Planck's constant 6.626 into 10 to the power minus 34 joule second divided by 4. 4 into pi value is 3.14 into uncertainty position 0.1 angstrom, given in angstrom. So multiply by 10 to the power minus 10. So that we have converted angstrom to meter unit by multiplying it with the 10 to the power minus 10. 10 to the power minus 10 into mass. Mass of electron we know that 9.1 into 10 to the power minus 31 kg. We have to simplify these powers as well as values. For the unit simplification, use a joule. Joule is equal to kg meter square per second square. So after the simplification, we get 0. Delta V is equal to 0.579 into 10 to the power 7 velocity. So meter per second unit. Meter per second is velocity. Or you shift the point towards right by one place. Okay. So 5.79 into 10 to the power 6 shifted towards right. So minus 1 meter per second. This will be the answer. That means delta V uncertainty error is 5.79 into 10 to the power 6 meter per second. Is to nimge error ಸಿಕ್ಕಿತು. Velocity measure ಮಾಡಲಿಕ್ಕೆ ಹೋದ್ರೆ we get this much of error. 10 to the power 6 meter per second. Next. A golf ball has a mass of 40 gram and a speed of 45 meter per second. If the speed can be measured with an accuracy of 2%, calculate uncertainty in the position. Mass of golf ball was given 40 gram. Mass 40 gram. So convert this gram into kg. 40 into 10 to the power minus 3 kg. And the speed is 45 meter per second. Then the speed can be measured within accuracy of 2%. What will be the uncertainty position? Delta x is how much? Uncertainty position is how much? Delta x. See, here delta v is not given, but they have mentioned the speed, velocity of that ball, that is 45 meter per second. Then what will be the uncertainty velocity? That we have to find out first. Accuracy is how much? 2%. Within accuracy of 2% means 2 in 100. 2 in 100. Right now? Andre 100 ಇದ್ರೆ 2% ಅಷ್ಟು ನಿಮಗೆ ಅನ್ಸರ್ಟೈನಿಟಿ ನಿರ್ದಿಷ್ಟವಾದ ಸಿಗುವುದಿಲ್ಲ, ನಿರ್ದಿಷ್ಟತೆ ಸಿಗುತ್ತೆ 2% ಅಷ್ಟು ಎರರ್ ಸಿಗ್ಬೋದು ನಿಮಗೆ. ಹಾಗಾದ್ರೆ 45 ಮೀಟರ್ ಸ್ಪೀಡಿಗೆ ಎಷ್ಟು ಎರರ್ ಇರುತ್ತೆ? 45 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ಗೆ ಎಷ್ಟು ಅನ್ಸರ್ಟೈನಿಟಿ? 45 into 2 by 100. 45 into 2 by 100. 0.9 meter per second. See, read the question again. Mass was given 40 gram. You need to convert gram to kg. Then speed was not given, not the uncertainty in velocity. 45 meter per second is its speed, not the uncertainty in position. that speed is measured with the result to percentage. ಅಂದರೆ 2% ಹೆಚ್ಚು ಕಡಿಮೆ ಇರ್ಬೋದು, ನಿಮಗೆ ಜಾಸ್ತಿ ಕಡಿಮೆ ಬರ್ಬೋದು. ಅದೇನು ಆ ನಿರ್ದಿಷ್ಟತೆ ಅಥವಾ uncertainty, called as uncertainty. So we have to calculate uncertainty in position. What is the step? 2% means 100 ಗೆ 245 ಗೆ ಎಷ್ಟಿದೆ? 0.9 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಗೆ ಹೆಚ್ಚು ಕಡಿಮೆ ಬರ್ಬೋದು. 0.9 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಅಷ್ಟು ಮಾತ್ರ ವೇರಿ ಆಗಬಹುದು ಸ್ಪೀಡ್. ಓಕೆ, which formula we have to use? Same delta x we have to calculate, you know. So delta x is equal to h by 4 pi m into delta v. Substitute here, h is 6.626 into 10 to the power minus 34 joule second divided by 4 pi 3.14 into mass 40 into 10 to the power minus 3 kg into delta v 0.9 meter per second. 0.9 meter per second. After simplification, we get delta v as 1.46 into 10 to the